Okay, let us speak for today and start it. We are going to talk about analog inputs and how we can do this job by Arduino board. First of all, you should know that analog signal is any continuous signal. What I mean by continuous signal is that, you know, um, between 0 and 1, even they tell us in our elementary school, there is a lots of number between them. But in the previous method that we have done, digital read and digital write, we just used 0 and 1. What we are going to learn today is we are going to work between 0 and 1. Okay? Then there is why we call it continuous signal or continuous range of numbers. Uh, for this continuous signal or continuous range of number, time which varying the future of the signal and is the representation of some other times varying quantities. So, for example, analogs to another times varying signal. It's differ from the digital signal in the term of a small fluctuation in the signal which are meaningful. Means that just a small change in our signal will create the new analog number that you can work with that. But on the other way, we have the digital signal, which use the discrete or discontinuous values. By contrast, or non-digital system will use the continuous range of the values to represent the information. All those digital representation are discrete. The information represented can be either discrete, such as number or letters, or continuous, such as sounds, image, and other measurements of continuous system. This is the difference between analog and digital. Uh, let's continue and see this analog uh, output better. You will see that I have one sine signal here, and by that I show you the digitalized waveform on that. This is the method when they are going to um, take the analog signal in the processor. There is the method that they call it digitization, and in that they will try to convert it or have some near value to the digital. As you see, this wave is splitted or chopped uh, in the form that if you see the digital form, I mean the red waveform, you will see that it's very near to analog, but it's not the real one. Then we have two concepts that we call it sample rate and word length, which have the key rule in doing the digitization work. Um, just have a look to this signal. Then more concept we have. One is resolution, which is the number of different voltage level that used to describe an input signal. And this resolution range from 256 state in for 8 bit to near to 4 milliard states or for 32 bits number. In Arduino, we use 124 state. It means 10 bits. And the smallest measurement things that we can have is 4.8 millivolt, which is derived from 5 volt divided by 124. Then the maximum sample rate is 10,000 K times per second. It's great, but in some application maybe it will not use. Anyway, it's very great advantage that we have in Arduino, and it will help us in various projects. Second things that you should know that most of the Arduino board have 6 or 12 analog inputs. For the board that we are working, I mean the Ono board, we have 6 analog pins, which they can measure the voltage between 0 to input voltage. Our board input voltage is 5 volt, but some other boards, suppose DUI or others, they have 3.3. Okay, remember that. And also the board, we label this analog pin with A. It means A0 to A5, it has the 6 analog pins which marked on the board, and you can see them. Suppose for the Arduino Mega, you have 16 bit of 16 pin for the um, analog, which is great and it's very useful for so many applications. Um, Note that reading an analog inputs is slow, and if we want to compare with the digital pins, this is because Arduino will measure the voltage using an internal reference voltage generator, which we call it DAC or digital to analog converter. And then it will compare the input voltage to the reference voltage. Then changing the reference voltage, comparing again, changing the reference voltage, comparing until these two will be equal. Then um, little bit this time is take time. One more thing that you should know that, as I said, the resolution for internal DAC is 10 bit. This means the maximum number that we can read for 10 bits is 2 power by 10 or 1024. So suppose if we have the numbers like uh, 0000 to uh, 1111, it means that we can have the range between 0 volt to 5 volt, which it means 5 volt is equal to 1023 and 0 volt is equal to 0. Remember that. Um, Digital inputs will come to Arduino as either on and off or high and low. Okay. Suppose if I want to say that my LED is turned on or my key is pressed, I will check that it's high or I will make it high. It's equal to 5 volts. But if I want to be sure that my key is not pressed or my LED is turned off, I should check or do the pin as low, which is equal to 0 volt DC. And analog inputs will come to Arduino as a range of numbers based upon the electrical characteristics of the circuit. Suppose 0 to 1023, and this gap between the numbers is 0.0049 volt per digit. Then if we read the times is 100 microsecond, it's equal to 10,000 or 10K a second. This pin, as we already discussed, is different in Arduino board by 3 parameters. One is that operating voltage. Second one is usable pins. And third one is maximum resolution. I mean that if you compare the Ono boards, the operating voltage for that is 5 volt, and usable pins for that is 6 pin, and maximum resolution is 10. Now you compare this with DUI, which operating voltage is 3.3, and usable pins are A0 to A11, and maximum resolution is 12 bit. Okay, or any other words that I say. Even you can compare it with mega. Operating volt is 5, but usable pins is near to 15 pins. And maximum resolution is again 10 bits. And remember, 12 bit, it's great. It's fantastic for the microcontroller. Even 10 bits also, it's fantastic. um, and one more point that in Ono it will take 100 microseconds to read analog inputs, and so the maximum readings is 10K times a second. If we put 0 volts into analog reads, it will be the value of 0, and if we put 5 volts into the analog read, so our value will become 1023 or 1024. This one number different has some reason that we will talk later. It's related to the atmega calculating and also frequency that we have. Then the voltage between 0 and 5 volts will give the numbers between these two values. And to receive the analog inputs, the Arduino will use the analogs of 0 to 5 pin on the most of the board. These pins are designed to use with the components that output analog information can be used for analog inputs. The command to read is analog read and pin number. Very simple. Pin number in this statement represent the pin where analog components is there. Suppose if I want to read the pin number of if I want to read the pin number of A2, very simple. I can use the analog read A2. It means that analog pin A2. Now I want to read. This function will use to program and address the analog pins to the Arduino board, and will also return the analog input reading, which is between 0 to 1023. Um, Now let us see some calculation that these numbers where they come. Suppose as each analog pin has 10 bits, so the number of the value of analog pin can be stored is 2 power by 10, which is equal to 1024, or if you want to start it from 0, is because 0 itself have the value, we can say 0 to 1023. And the voltage can address the 5 volt. We can conclude relation between the store value voltage to my analog pin and then measure that. What should I do? It's very simple. You will see that 0 volt is equal to 0 value. 5 volt is equal to 1023. Then each volt is equal to 204 or 204.6 values. Or we can find that each value is equal to 4.9 millivolt. Some number here I wanted, which is that you know. As for one is this table. It will give you rest of the as the digital of the thing you can write and digital. Okay, let us see actual read. One is on a two command which help us read and specify the pin numbers up to A0 to A5 or VC. We can specify A0 to A5. We will set that which pin of our Arduino board, and then uh, how much should be this value. This value, I mean the second term here, is the number which will be from between 0 to 255. And it has just some integer value. There is lots of analog part. There is lots of application that I'm using. One of the famous things that when you connect any sensors to this value, when you connect any value to this in any sense, you can measure that. One of the things is that we have the bridge for the resistor. We will talk later. But most of the sensors that we work, something like LDR and that, they have the performance like resistor. And then we can measure this part or this resistor value with the help of some bridge and change it into the form of voltage and then measure the value. I should talk more regarding this part for you, but and we call it potentiometer or variable resistor, which when you will turn it or move it, the value for resistor will be changed. Then if you connect it like what I have done here, you can then if you turn it to right and left, the value of resistor will be changed. Value of resistor, which is related to different value of voltage. The first example that we will do, it's based on these three inputs. What we have done here, first we should declarate that which analog pins we are using. Okay, something that here I use, it's wrong. It should be 0. Okay, this value should be 0 because I connect to this pin number 0, and then very simple because I want to show it on serial monitoring. First, I do the initialization for serial monitoring. Then in the loop, first simply I read the analog read or analog read value and then print the value. Very simple. Whenever I will move my three inputs, then something that I will have on the serial should be out. Okay, this example, it's already on analog read serial out example. And by that, you can read the value of the potentiometer. This is the example number one that it shows us how to read the analog value. Just remember analog read and now we print this and then you know more edit pin numbers. Put statement can directly come here. No need to have more some in Arduino board, and read is okay. Read part is no problem. One part is that they want to generate the analog. How they should do. These pins, as we talked before, we call it PWM or parts with modulation, which can use to light a LED at varying brightness or driving the motors with varying speed. This is one of the fantastic job and perfect things that they have done in microcontroller, especially in the Arduino. They make it very simple. It's very useful and it's very nice. Then it's very simple to use. After a call to analog write, the pin will generate the steady some rectangular wave of a specified duty cycle until the next call to the analog write or digital read or a call a digital read or digital write or on the same pin. But these pins are limited in Arduino board. Suppose with Ono, we have just these six pin, pin number 3, 5, 6, 9, 10, and 11, as you can see here. And remember that the PWM frequency is 490 Hz. Okay. In pin number 5 and pin number 6, we have 980 Hz. Okay. You can compare these to suppose mega. You see, number of pins are different. Pin number 40 to 46 and 2 to 30. Or you can compare to the DUI, which PWM frequency is also different. Okay, now one more question. We want to set the output to the LED proportional to the values read from the potentiometer. Means that I will take the potentiometer and based on that, I will control the lightness of my LED. Okay. Think that I connect LED pins number 9. Analog pins that I want to read is number 3. Okay, very simple. First, we will specify the mode of LED, then in the loop, we will read the analog pin, and then in the loop, we will read. After that, this is some step that we have done. Whatever they will read, we will divide it by 4. The output will generate on pin number 5 and 6 will have the higher than expected duty cycle. And this is because the interaction with the two function of millis and delay, which share the same internal timer used to generate those PWM. This will notice mostly on low duty settings. Suppose if you want to have the duty cycle between 0 and 10, and may result in the value of 0 not fully turning off the output on pin number 5 and 6. Just remember this, and it's better that in some specific application you use pin number 5 and 6. One more example. Suppose I want to have the different lightness in my LED pins. Okay. Here I show. Suppose I connect the LED to pin number 11, and then I'm going to generate the value, a different value of light for my LED. You will see that 255 is when I have the maximum, and 0 is when I have the uh, minimum lightness for that. This is another example that we can have. Even Arduino can do the analog reading through the loops, and you can have this. Just have a look to this example or to this code. Just I will give you 1 minute, 2 minutes to analyze it. Please think for that. Hmm. pin number 11, we put it as the output, and then we specify some value in the form of loop from 255, and then we will generate the analog pin through that. With this program, which they call it fade in, fade out, you can turn on and turn off the LED pin. Okay, which is connect to the pin number 11. This is also again that program, but just now I type it. Okay. Sometimes we need the scale for the value. Then there is one specific function which we call it map, and through this map you can tune the voltage between or reading between 0 to 255 to 0 to 1023. Means that between 8 bit and 10 bit you can move. It's very simple that you should just use this value. We will see in the example later how it will work, and how we should use this function later. Without this also we can work, but this one will make your analog reading more precise. Okay, as I tell you, most of the sensors are performed in the form of varying the resistance. Then, if I want to measure the value of resistor, suppose some LDR type or any other, I should make the circuits like this: R1, R2, and V out. This R1 can be our sensors, which I will specify with S. This one is some fixed value, which generally they will put 1K or 10K resistor. And this is the pin which will connect to Arduino board. And this is generally is 5 volt and ground. Then if I want to know the V out, means that the voltage which I can read from my Arduino, the formula will give me that how to calculate and know this voltage. Here, what I have done as the next stage, I try to show you how to access the different resolution for the Arduino board, which we can have the 8-bit resolution, 16-bit resolution, 12-bit, and 10 bits. And the point is just that just you should specify the resolution of your Arduino board to what you want. If you want to work with 10-bit resolution, just put analog read resolution 10 statement, or 16, or 12, or 8. You know, for Ono, we can use just up to 10 and 8, but for rest of them, we have um, other resolution that you can see here. Um, then for today, uh, um, for today uh, experiment, you can use these circuits that just right now I will put it on the group, and then you can use it as the hardware design part, and then implement the same uh, program that we have. Then task number it's become 8 is like this, that you should um, do the example that I put here, and send it again with simulation for me, and by that um, we will again see your assignment for today lecture. Just right now I shared the diagram, and this slides also is on the mock system. You can have them and code, and then based on example, uh, we you will do the simulation. Okay. Uh, Before ending today lecture, I wanted you see some clips which is related to Arduino board and Arduino board performance. Uh, Let me once again share this video. Then what we learned today was that analog read, analog write, and then combine it to the serial monitoring. All the example, if you see, it's like that. Okay, let us see some video about working with Arduino board. This is the use of Arduino Nano and Ono, and this is the Nano one. You will see that it's very cheap. 8x8 LED integrated module. You see that it's also very cheap module. Okay, how it will connect is that it's going to connect the pins, 5 wires to that, and then based on VCC ground, it's go, and then digital ins and other pins will connect. This is these circuits. It's based on the module. Okay, there is some library for this module that I will teach you later how to add the library, and then you can have the code. And after running the code into your Arduino board, it's connected and load. Even you can do some change by that, but or any other things that you want to write on that, then you will see that it will come out. Okay, if you want to have more, yes, more LED also you can do and connect to these. Okay. Another project can be these robots which using the ultrasound sensors, and yeah, with 3D printer they made the foods, and also they put the ultrasonic sensors, some servo motors there, and 8x8 LED matrix, and some Bluetooth, some other things that they add inside the robots that they made. And the first one, Now they can control it with a smartphone here. Okay, this app, you can even write that. Okay, then various work and various job they will do by controlling with the application. Then they can generate the sound, different sound. Then they generate the different sound to these, and robots will be controlled by this. Okay. This is the some parts that I want you learn and see that even I use sensors on sensors, and you can connect the motor. Then you can do the measure. Okay, this LCD we will soon will learn how to work with this LCD part, and then here I'm going to connect it to the distance. Okay, as you see, they can measure the distance between the sensors and that. Okay, another project can using DHT sensors, which is the humidity and temperature sensors. Put it there. I will teach. See that they can connect that value and put it the value and how and for keypad think further anything with your maybe you can have some joystick to controlling. You see, this is the analog reading that. Okay, then what you need that you need some LEDs. This job we have done before, and just I bring it for you to see the values. Okay, that was some project that people also do with the Arduino. Please read this PPT and do the simulation for the parts. Let us try that. Can we can once again to do the attendance, because that last time I couldn't do it, but because last time I couldn't do. Let us see that can we do the attendance now or no.